When we stand under a clear night sky, somewhere far from the city lights, perhaps in the high desert of the Atacama or the quiet valleys of the Himalayas, we feel an overwhelming sense of immediacy. The stars feel present, hanging there like lanterns in a dark room, watching us as we watch them. We feel a connection, a sense that we are sharing a moment with the cosmos. But this intimacy is a magnificent illusion. The universe you see with your eyes does not exist. It is a ghost. It is a memory. It is a library of ancient letters that have only just arrived at your doorstep, telling you stories of a world that has long since moved on. The fundamental rule of our reality, the iron law that governs every atom and every galaxy, is that information cannot travel instantly. It is bound by a speed limit, the speed of light, 300,000 kilometers per second. It sounds fast. It is fast enough to circle the Earth 7 times in a single heartbeat. But on the scale of the cosmos, light is agonizingly slow. It is a snail crawling across the face of a continent. Because of this speed limit, we are trapped in a perpetual state of delay. We never see the universe as it is right now. We only see it as it was. When you look at your friend across the room, you are seeing them a few nanoseconds in the past. When you look at the moon, you are seeing it 1.3 seconds ago. You are never truly in the present with anything outside of your own mind. Now ask yourself, does the present moment even exist if we can never share it? This delay becomes haunting when we leave the surface of our world. Look at the sun. That blinding ball of plasma warming your face is 8 minutes and 20 seconds old. If the sun were to suddenly vanish, to simply blink out of existence this very instant, we would not know. We would continue to orbit a ghost. We would feel its gravity and see its light for 8 minutes and 20 seconds. We would go about our morning coffees and our commutes, completely unaware that the anchor of our solar system was gone, until suddenly the darkness arrived. We live in a bubble of ignorance, protected by the lag of light. Push further out. In late 2023 and continuing into 2024, the Voyager 1 spacecraft, the furthest human-made object in existence, began sending back garbled data. It is currently over 24 billion kilometers away. When NASA engineers send a command to fix it, they must wait 22 hours for the radio signal, travelling at the speed of light, to reach the probe. Then they must wait another 22 hours for the reply. Almost 2 days of silence. 2 days of not knowing if the machine is dead or alive. This silence is the breath of our prison cell. Even within our own solar neighbourhood, the light lag isolates us, turning conversations into slow-motion exchanges of historical records. But the solar system is merely our backyard. The true melancholy sets in when we look at the stars. The light from Proxima Centauri, our nearest neighbour, takes over 4 years to reach us. When you look at it, you are seeing light that started its journey before the COVID-19 pandemic ended. If a civilization there turned on a powerful laser beacon today to say hello, we would not see it until the late 2020s. We are always out of sync. We are always talking to the past. And as we look deeper, the time difference stretches into the incomprehensible. The bright star Sirius is 8 years in the past. Betelgeuse, that red giant in the shoulder of Orion, is around 650 years away. When you look at Betelgeuse, you are seeing light that left the star when the Black Death was ravaging Europe. We know that Betelgeuse is dying. It is unstable, pulsating, ready to explode as a supernova. It is entirely possible that it has already exploded. It might have detonated 500 years ago. But the light of that explosion, the news of its death, is still travelling across the vacuum, racing towards us, but not yet here. We look up and see a living star, but we might be staring at a corpse. The sky is a graveyard, filled with the ghosts of stars that have already perished, but whose death notices have not yet crossed the gulf of space. Here is a number that might scare you. We estimate that for the most distant galaxies we can see, the ones that appear as faint red smudges in our most powerful telescopes, the light has been travelling for over 13 billion years. But because the universe has been expanding that whole time, dragging the galaxies away from us, those galaxies are now over 46 billion light years away. They are gone. They have moved beyond our reach forever. In fact, 97% of the galaxies in the observable universe are already unreachable. Even if we could travel at the speed of light today, we would never catch them. They have crossed a cosmic horizon, carried away by the relentless expansion of space. We can still see their ancient light, like a postcard from a friend who has gone to a place where no mail can ever return. But the physical objects themselves are lost to us. We are looking at a universe that has effectively already left the building. This realization forces a profound shift in how we understand our place. We are not explorers standing on the edge of a frontier. We are archivists sifting through a dusty library. The universe we study is a history book. The James Webb Space Telescope, which launched recently and has begun rewriting our textbooks in 2024 and 2025, is not a spaceship. It is a time machine. Its giant gold-coated mirror was designed to capture infrared light, light that has been stretched by the expansion of the universe as it travelled through the dark for billions of years. One of the most startling discoveries came in mid-2024 with the confirmation of a galaxy known as Jade's GSZ 14-0. The light from this galaxy started its journey only 290 million years after the Big Bang. This was the cosmic dawn, the era when the first lights turned on in the universe. But what Webb found was shocking. This galaxy was not a chaotic, infantile mess. It was bright, massive, and structured. It had carbon and oxygen, elements that should not have existed in such abundance so early. This tells us that the universe grew up faster than we ever imagined. It implies that in the darkness of the early cosmos, stars were living and dying with ferocious speed, polluting the cosmos with the ingredients for life much earlier than we thought possible. But think about what that light represents. Those photons from Jade's GSZ 14-0 have been travelling for 13.5 billion years. They have passed through clouds of primordial gas. They have dodged the gravitational pull of forming galaxy clusters. They have surfed the expanding fabric of space-time itself. And finally, after that eternity of travel, they slammed into a detector on a telescope built by a species of hairless apes on a small, watery rock. And in that collision, the photon died. Its journey ended just to tell us, I was here. We are the recipients of a message sent before Earth even existed, before the sun ignited, before the Milky Way had even fully formed. There is a deep sadness in this. We are desperate to know if we are alone. We scan the skies for signals, for techno-signatures. But the light barrier means that even if the universe is teeming with life, we might never know. A civilization could have risen in the Andromeda galaxy, flourished for 1 million years, built wonders beyond our comprehension, and then died out 10 million years ago, and we wouldn't know about it for another 2 million years. The light from their greatest achievements is still only halfway to us. We are separated not just by distance, but by time. The universe could be a bustling metropolis, but because of the delay of light, it looks to us like a silent wilderness. We are like people living in isolated cabins in a vast forest, where a shout takes a lifetime to reach the nearest neighbour. By the time you hear them, they are already gone. But what if we are looking at this upside down? What if this delay is not a prison, but a form of preservation? Because light takes time to travel, nothing in the universe is ever truly lost. The history of the cosmos is encoded in the light beams crisscrossing the void. If you could teleport instantly to a planet 65 million light years away and look back at Earth with a powerful enough telescope, you would not see humans. You would see dinosaurs roaming the continents. The light reflected off the scales of a T-Rex is still travelling through the Milky Way right now. The image of the asteroid impact that killed them is expanding outwards in a sphere of light, a movie reel of our bad day, playing out for anyone in the galaxy to watch. This means the universe is a holographic record of everything that has ever happened. Every photon is a data point. The light from the supernova that created the iron in your blood is still out there. The light from the first fires sparked by early humans is still drifting through the spiral arms of our galaxy. We are confined to the Earth, yes, as we discussed in our earlier reflections on the impossibility of escape. We cannot leave this rock physically. But through light, our image, our story is escaping. We are broadcasting our existence to the cosmos at the speed of light, an expanding sphere of us that will continue to grow long after our planet is dust. However, there is a limit to this view, a hard wall we cannot see past. We call it the surface of last scattering, or the cosmic microwave background. This is the oldest light in the universe. It comes from a time about 380,000 years after the Big Bang, when the universe finally cooled enough for light to travel freely. Before that, the cosmos was a hot, dense fog of plasma. Photons were trapped, bouncing around like pinballs in a machine. We cannot see past this wall. It is an opaque curtain of fire that surrounds us in every direction. When we point our radio telescopes at the blank patches of the sky, we hear a hiss. That static is the stretched out afterglow of the Big Bang. It is the heat of creation, cooled down by 13 billion years of expansion until it is just a whisper of microwaves. This background light tells us something profound about the geometry of our prison. It is remarkably uniform. It is the same temperature in every direction to within 1 part in 100,000. This smoothness is what allowed us to exist. If the early universe had been chaotic and lumpy, it would have collapsed into black holes or thinned out so fast that stars never formed. We exist on a knife edge of probability, revealed by this ancient light. But it also reminds us of our isolation. We are sitting in the center of a sphere of observation, defined by the speed of light. We are at the center of our own personal, observable universe, and every observer in the cosmos has their own sphere, their own horizon. The melancholy deepens when we consider what light actually is. We think of it as illumination, as clarity, but in quantum mechanics, light is enigmatic. It behaves as both a particle and a wave. It is a packet of energy, the boson. When we say we see something, what is really happening? A stream of photons is hitting the retina of your eye, triggering a chemical reaction that sends an electrical impulse to your brain. You are not directly touching the world. You are reconstructing it from the bombardment of particles. Your brain paints a picture of the universe based on this trickle of data. And here is the catch. Our eyes are pathetic sensors. The visible light that we see, the rainbow of colours from red to violet, is a tiny, almost insignificant slice of the electromagnetic spectrum. It is less than 1% of the light that exists. Imagine you are in a grand concert hall listening to a symphony, but your ears can only hear one single note, perhaps the middle C on a piano. You are deaf to the violins, the drums, the flutes, the deep resonance of the cellos. That is how we view the universe. We are blind to the radio waves, the microwaves, the infrared, the ultraviolet, the X-rays, and the gamma rays. The universe is screaming at us in all these frequencies, telling us stories of violent black hole collisions, of neutron stars merging, of clouds of cold gas birthing new solar systems. But we cannot see them. We evolved to see only the light that passes through our atmosphere and is emitted by our specific yellow star. We are tuned to the sun. We are not tuned to the universe. For most of human history, we were oblivious to this invisible cosmos. We looked up and saw a peaceful, static canopy. We wrote poems about the eternal, unchanging stars. We were wrong. The universe in X-rays is a violent, chaotic slaughterhouse. The universe in radio waves is a pulsating disco of quasars and pulsars. By unlocking these other forms of light, we have realized that the cosmos is not a serene place. It is a place of unimaginable energy and violence. In 2025, new data from the Chandra X-ray Observatory, combined with Webb's infrared vision, showed us the heart of our own galaxy in a way we had never seen. We saw the supermassive black hole, Sagittarius A star, not as a dark void, but as the conductor of a chaotic orchestra, flinging gas and stars around at relativistic speeds. We saw the scars of past explosions that would have sterilized any life nearby. We saw that our quiet corner of the galaxy, out here in the suburbs, is a rare oasis of calm. This reinforces the feeling that we are sheltering in a storm. The light that reaches us is filtered, weakened by distance, safe for our fragile biological eyes. If we were closer to the action, the light would kill us. A gamma ray burst, a focused beam of high-energy light from a dying star, could wipe out our ozone layer in seconds if it happened nearby. We survive only because we are far away, hidden in the dark, watching the fireworks from a safe distance. So, light is a double-edged sword. It is our only messenger, bringing us news of the cosmos, but it is also the warden of our prison, limiting how fast we can learn and how far we can see. It is the barrier that keeps us from ever knowing the true now of the universe. And it is a reminder that we are small, biological accidents huddled around a yellow star, trying to decipher the signals from a vast, indifferent dark. We build telescopes to extend our vision, to break out of our biological limitations. We have built eyes that can see the heat of dying stars and the radio whispers of cold hydrogen. But every time we build a bigger telescope, we just find more universe. We find more galaxies, more darkness, more questions. It feels like walking into a mist. You take a step forward and the mist clears a little, but you see that the path goes on forever and the mist ahead is just as thick. As we stare into this mist, we must confront the reality of the redshift. As space expands, it stretches the light travelling through it. Blue light becomes red light becomes infrared becomes radio. The light loses energy as it travels. It gets tired. It fades. This means that the universe is slowly fading away from us. In the far, far future, billions of years from now, the expansion will have stretched the light from other galaxies so much that it will become undetectable. Future civilizations on Earth, if they exist, will look up and see nothing but our own galaxy. They will think the Milky Way is the entire universe. They will have no way of knowing about the Big Bang, or the expansion, or the billions of other galaxies that once shone in the sky. The evidence will have been erased by the stretching of light. We are living in a privileged time. We are living in the brief window of cosmic history where the light from the deep universe is still bright enough to see. We are the lucky ones who get to know the truth before the darkness closes in. We are the archivists at the end of the golden age of astronomy, frantically writing down everything we see before the library lights go out. But this light, this fading, ancient, stretched light, interacts with matter in ways that are even more peculiar. It doesn't just travel, it touches. And when it touches, it changes things. It drives the chemistry of life. It pushes against the dust of comets. It exerts pressure. Light is not just a ghost, it is a physical hand. And this brings us to the most intimate connection of all. The light you see, the light that enters your eye, is physical matter. It is not an abstract concept. Photons are real. When you look at the Andromeda Galaxy, a photon that has travelled for 2.5 million years ends its journey by physically striking a molecule of rhodopsin in your retina. It changes the shape of that molecule. You are chemically altered by the light of the universe. You are not just an observer, you are a participant. The universe is touching you. This physical connection bridges the gap of time. That photon from Andromeda is a physical piece of the past that has arrived in your present to become part of you. In a way, we are eating the light of the stars. We are metabolizing the history of the cosmos. Our consciousness, our ability to perceive this vastness, is built out of these interactions. We often feel small when we look up. We feel insignificant against the scale of the billions of light years. But remember, the universe has no eyes. The stars cannot see themselves. The galaxies cannot marvel at their own structure. Without us, without biological observers to capture and process the light, the universe would be playing to an empty theatre. The light would travel through the void, hitting nothing, seeing nothing, meaning nothing. It is only when the light hits a retina or a telescope mirror that feeds data to a mind that the universe becomes known. In this sense, we are not just passive recipients of light, we are the destination. We are the place where the light finally lands and becomes information, becomes wonder, becomes meaning. We are the cosmic mistakes that learn to see. And as we stand here, trapped on our little rock, unable to leave, unable to escape the prison of the speed of light, we realize something profound. The light didn't just shape our knowledge of the universe, it shaped us. We are creatures of the light, evolved to interpret it, dependent on it for our food and our warmth and our knowledge. We are the universe's way of looking at itself in the mirror. But mirrors can be deceiving, and the image we see in the mirror of the night sky is distorting. It is bending. It is not showing us the straight lines and simple geometries we learned in school. Gravity, the great sculptor of the cosmos, has its hands on the light, twisting it, bending it, warping the very image of reality. This bending of light, this gravitational lensing, is the next layer of the illusion. It shows us that space itself is not what we thought it was. It is not a stage, it is a lens. And through this lens, we see monsters. We see rings of fire where there should be stars. We see the same galaxy appearing in 4 places at once. We see the funhouse mirror of the cosmos. And it is here, in the warped and twisted light of the deep universe, that we find the dark counterparts to our bright messengers. If light reveals the universe, then darkness conceals it. But we have learned that the darkness is not empty, it is heavy. It is pulling on the light, fighting against it. We are about to enter the realm of the invisible, the unseen forces that dictate the path of the light we cherish. We have spent this time looking at the messengers, the photons that cross the void. But what of the void itself? What of the silence between the stars? The light tells us where the matter is, but the gaps tell us where the mystery lies. As we move deeper into this story, we must leave the comfort of the visible spectrum and ask, what happens when the light fights against the dark? And who is winning? The answer lies in the invisible, in the things we cannot see, but which we know must be there because of how they wrestle with the light. We are moving from the library of memories into the hidden basement of the universe, where the true machinery is kept. And the first thing we notice when we descend into the dark is that the light is not just a messenger, it is a prisoner, struggling to break free. For decades, we believed that light travelled in straight lines. We assumed that if we looked at a distant star, we were looking directly at it, like sighting a target down the barrel of a rifle. But in the early 20th century, we realized that the universe is not a rigid box of Euclidean geometry. It is a fabric, a heavy, malleable fabric. And when you place a massive object, like a sun or a galaxy, onto that fabric, it sags, it curves. This is gravity. It is not a force reaching out to grab things. It is the curvature of the space itself. And because light must travel through space, it must follow these curves. It must surrender to the landscape. When a photon passes near a massive galaxy cluster, it falls into the valley created by that gravity and climbs back out. Its path is bent. This means the image we see is not where the object truly is. We are looking at a mirage. The gravity of the foreground galaxy acts like a giant, imperfect magnifying glass, smearing the light of the background galaxy into arcs, rings, and multiple copies. We call this gravitational lensing. It is beautiful, creating these Einstein rings of warped light in the darkness. But it is also a reminder that our view is fundamentally unreliable. The universe is a funhouse mirror. The light is lying to us about position, about shape, about number. But the lie reveals a deeper truth. By measuring how much the light bends, we can weigh the monster in the dark. We can calculate how much mass is required to twist the light that violently. And this is where the story turns from a physics lesson into a ghost story. In the 1970s, an astronomer named Vera Rubin looked at the rotation of galaxies. She watched the stars on the edges of spiral galaxies. According to the laws of physics and the amount of glowing matter, stars and gas that we could see, those outer stars should have been moving slowly. The gravity from the visible centre shouldn't have been strong enough to hold them at high speeds. They should have flown off into the void, like water spinning off a bicycle tyre. But they didn't. They were moving incredibly fast, yet they stayed in orbit. Something was holding them. Something massive. Something invisible. We did the math again and again. We looked at galaxy clusters where the light was being warped into extreme shapes. We calculated the mass of all the stars, all the gas, all the dust, everything that emits or reflects light. And the numbers didn't add up, not even close. There was missing mass, a lot of it. To explain the gravity we were seeing, there had to be 5 times more stuff than what we could see. We call it dark matter, but the name is a placeholder for our ignorance. It is not dark like a shadow. Shadows are caused by light being blocked. This substance does not interact with light at all. Light passes right through it. It doesn't reflect, it doesn't absorb, it doesn't emit. It is completely transparent. It is a ghost. And yet it has gravity. It is heavy. It is the scaffolding of the universe. The galaxies we see, the bright spirals and golden ellipticals, are just the fairy lights strung up on a massive invisible Christmas tree. The tree is the dark matter. We are just the decoration. Now, ask yourself, how does it feel to know that the majority of reality is hiding from you? If you were to take a pie chart of the universe, the normal matter, the stuff that makes up you, me, the earth, the sun, the stars, the gas clouds, everything we have ever seen or touched, makes up less than 5% of the cosmos. 5%. That is it. That is the sum total of our known reality. The rest is the dark sector. We are the foam on the ocean. We are the anomaly. We evolved to perceive matter that interacts with light, but we live in a universe dominated by matter that does not. We are walking through a crowded room, but we are blind to 95% of the people standing next to us. This invisible presence isn't just out there in deep space. It is right here. Dark matter is passing through your body right now. Billions of particles every second, streaming through the earth, through your house, through your DNA, without leaving a trace. We have built detectors deep underground, tanks of liquid xenon buried in gold mines, waiting for just one dark matter particle to accidentally bump into an atom so we can see the flash. We are still waiting. The silence is deafening. But the story gets darker. If dark matter is the glue holding the universe together, pulling things inward with its gravity, there is another player in the game, a player that pushes. In the late 1990s, we tried to measure how fast the universe was slowing down. We knew the Big Bang threw everything outward, but we assumed gravity would eventually pull it back, like a ball thrown into the air, eventually slowing and falling. We looked at distant supernovae, using their light as standard candles to measure distance and speed. We expected to see deceleration. We expected to see the cosmos breaking. We saw the opposite. The universe is not slowing down. It is speeding up. The galaxies are rushing away from us faster and faster every day. Something is pushing them. Something is creating more space between the galaxies, driving the cosmos apart. We call this dark energy. And if dark matter is the ghost, dark energy is the monster. It makes up roughly 68% of the energy budget of the universe. This discovery, confirmed and refined by the Euclid mission in the mid-2020s, paints a terrifying picture of the future. Dark energy is relentless. It does not dilute as the universe expands. It is a property of space itself. The more space there is, the more dark energy there is, which pushes harder, which creates more space. It is a runaway feedback loop of isolation. Here is a number that might scare you. We have calculated that because of this acceleration, the universe is dissolving. Not the matter itself, but the connections. The galaxy clusters that are not gravitationally bound to us are being carried away faster than the speed of light. They are exiting our observable universe. Every second, a portion of the universe disappears from our future forever. We are losing contact. If we could wait long enough, trillions of years, all the other galaxies would disappear from our sky. The Milky Way would be left alone in a limitless black void. Future astronomers would look up and see nothing but our own stars. They would have no evidence of the Big Bang, no evidence of the expansion, no evidence of the other trillions of galaxies. They would conclude that our galaxy is the entire universe, static and eternal. They would be wrong, and they would have no way of knowing they were wrong. This is the ultimate tragedy of light in our universe. It is a resource that is being depleted. The information is being erased. We are living in a time of clarity, but we are heading toward a time of ignorance. The universe is effectively deleting its own history file. But let us pull back from the abyss of the far future and look at how this manipulation of light affects us right now in the era of high-precision cosmology. We are finding that even our best maps might be wrong. We are currently facing a crisis in physics called the Hubble tension. It sounds technical, but it is actually a crack in our understanding of reality. When we look at the early universe, the light from the cosmic microwave background, and calculate how fast the universe should be expanding today, we get one number. But when we look at the local universe, using the light from supernovae and pulsating stars, we get a different number. The universe is expanding faster than it should be. The two measurements, both extremely precise, both relying on our best understanding of light, do not agree. It is as if the ruler we are using to measure the cosmos is changing size depending on where we look. This suggests that there is something fundamental we are missing. Perhaps our understanding of gravity is wrong. Perhaps there is a new, exotic type of particle we haven't found. Or perhaps, and this is the most unsettling possibility, the light itself is changing in ways we don't comprehend as it crosses the vast distances. We are trying to read a book where the letters are rearranging themselves as we turn the pages. The Euclid telescope and the upcoming Nancy Grace Roman telescope are our attempts to solve this. They are mapping the distortion of light across billions of galaxies to trace the skeleton of dark matter and the muscle of dark energy. But every image they send back, every map of the invisible web, reinforces the same feeling. We are small. We are made of the minority stuff. We are the flotsam on a dark ocean, drifting apart. But what if we are looking at this upside down? We treat this invisibility as a failure of our vision. We mourn the fact that we can't see the dark sector. But perhaps this blindness is a mercy. If our eyes could see all the radiation, all the gravity, all the dark matter, the sky would be a blinding, chaotic scream of data. We would be overwhelmed. Our biological eyes evolved to see a narrow band of sunlight because that is what was useful for survival on the African savanna. We needed to spot predators in the grass, not quasars in the deep field. Our limitations are what allow us to focus. They allow us to function. This brings us to the second prison. We have talked about the prison of the speed of light and the prison of Earth's gravity. But there is a prison closer to home. It is the prison of your own skull, the umwelt. This is a biological concept. It describes the self-centered world that every organism lives in. A tick on a blade of grass senses only the heat and the butyric acid of a passing mammal. That is its entire universe. It doesn't know about music or stars or mathematics. It lives in a smell-temperature world. A bat lives in a world of texture and distance painted by sound. A flower lives in a world of ultraviolet patterns and polarization that we cannot see. We humans are no different. We live in a human umwelt. We think that the colours we see are objective properties of the universe. We think a rose is red. But the rose is not red. The rose is a collection of atoms that absorbs certain wavelengths of light and reflects others. Red is a sensation that happens inside your brain. It is a user interface code. The universe itself is colourless. It is silent. It is scentless. It is just matter and energy and vibration. The world you experience, the blue sky, the green grass, the warmth of fire, is a hallucination created by your brain to help you navigate the quantum soup. You are not looking out a window. You are watching a movie on the back of your eyes, and the projector is your own mind. This realization creates a profound sense of isolation. I can never know if the red you experience is the same as the red I experience. We are locked in our own private theatres, watching our own private screenings of the universe. We assume we are watching the same movie, but we can only verify it by comparing notes. Is that apple red? Yes. But the internal experience remains forever inaccessible. This internal isolation mirrors the cosmic isolation. Just as we can never touch the galaxies because of the speed of light, I can never truly touch your consciousness because of the barrier of our biology. We are signaling to each other across the void, using sound waves and light waves, words and gestures, hoping that the message is received, hoping that we are not alone. And yet, despite these layers of separation, the light lag, the expansion, the biological filter, we have managed to construct a shared reality. We have used the very light that limits us to transcend our limits. We have built machines that see for us. In 2024, the Event Horizon Telescope gave us a refined image of the supermassive black hole at the centre of our galaxy, Sagittarius A star. The image is a blurry orange donut of light. It looks simple, but think about what it represents. That orange light is radio waves that were emitted by hot gas swirling around the drain of a gravitational singularity. That light had to travel 26,000 light years, dodging dust clouds and star clusters. It was caught by a network of telescopes spanning the entire Earth, from Antarctica to Spain to Hawaii. We had to combine the data from all those telescopes, using atomic clocks to sync them down to the nanosecond, effectively turning the entire planet Earth into a single giant eye. We had to build an Earth-sized eye to see the invisible heart of our own galaxy. That blurry orange ring is the silhouette of the unknown. It is the edge of our reality. Inside that ring, inside the event horizon, the laws of physics as we know them break down. Time stops. Space becomes infinite. It is a hole in the fabric of the story, and we are standing on the edge, peering in, using the last scraps of light that escaped to map the geography of the abyss. This is the bravery of our species. We know we are cosmic mistakes. We know, as I have said before, that the universe was not made for us. It is hostile, it is vast, it is indifferent. It hides its true nature in the dark sector. It separates us with impossible distances. And yet, we refuse to look down. We refuse to just eat and sleep and reproduce. We insist on looking up. We insist on catching the ghosts. We insist on drawing maps of places we can never visit. But there is a cost to this knowledge. The more we learn about the light, the more we realize how fragile our connection to the universe really is. We are beginning to understand that the constants of nature might not be constant. We used to think the speed of light was a fixed number, written in stone at the beginning of time. But some theoretical models, pushed forward by the discrepancies we are seeing in the 2020s, suggest that the speed of light might have been different in the early universe. If that is true, then our measurement of age, of distance, of size, it all shifts. The ground beneath our feet is not stable. We are drifting on a raft of assumptions. And what happens when the light itself becomes a weapon? We often think of the sun as a benevolent provider. But in 2024 and 2025, as the sun reached the peak of its 11-year activity cycle, we were reminded of its power. Massive solar flares, coronal mass ejections, slammed into our magnetic field. We saw auroras as far south as Texas and Italy. Beautiful, yes, but also a warning. That light, that charged gas, has the power to fry our satellites, to crash our power grids, to silence our internet. The very technology we use to study the universe is vulnerable to the temper of the star that keeps us alive. We are playing with fire, and the fire is getting restless. The light that reveals the universe is also the radiation that destroys DNA. In space, outside the protective blanket of our atmosphere, the cosmic rays, high-energy particles travelling near the speed of light, are like microscopic bullets. They tear through cells, they shatter chromosomes. This is one of the reasons why, as I have argued, leaving Earth is likely impossible. We are creatures of the shelter. We evolved in the shade of the atmosphere. To step out into the raw light of the cosmos is to step into a microwave oven. The universe is toxic to our biology. The light is not just information, it is radiation. So we are caught in a paradox. We are desperate to see the light, to capture it, to analyze it. It is our only link to the greater reality. But we must hide from it to survive. We build telescopes to gather it, but we build magnetic shields and thick atmospheres to block it. We are like moths drawn to a flame that will incinerate us if we get too close. This tension defines our existence. We are observers trapped in a bunker, watching the war of the universe through a periscope. As we move deeper into this exploration, we must consider not just the light that comes to us, but the light we send out. We have been broadcasting our existence for a little over a century. Radio waves, television signals, radar pulses. A sphere of human noise is expanding into the galaxy at the speed of light. It is a bubble of us, about 200 light years across. It contains Hitler's speeches, the moon landing, soap operas, pop music, and the internet screaming data. But the galaxy is 100,000 light years across. Our bubble is a tiny dot. And due to the inverse square law, our signals get weaker as they travel. By the time they reach even the nearest stars, they are indistinguishable from the background static of the universe. We are whispering in a hurricane. We want to be heard. We want to be found. We want to know that we matter. But the physics of light ensures our anonymity. Unless we focus a laser directly at a specific star with the power of a planetary power grid, no one will ever know we were here. We are shouting into a pillow. This brings us back to the feeling of the cosmic mistake. If we were meant to communicate, if the universe was designed for life to interact, the laws of physics would be different. Light would be faster, gravity would be weaker, the universe would be smaller. But it isn't. The design of the cosmos, if you can call it a design, seems optimized for isolation. It maximizes the distance between observers. It maximizes the silence. It is a machine for creating loneliness. And yet, in this vast, lonely dark, there is beauty. The beauty is not in the design, but in the witnessing. The fact that the light, after travelling for 1 billion years through the cold and the dark, can find a landing strip in the human eye is a miracle of chance. The fact that the universe can look at itself is the anomaly. We are now standing at a threshold. We have looked at the speed of light as a delay. We have looked at the bending of light by gravity. We have looked at the invisible universe that outweighs the visible. But we have not yet talked about the beginning, the moment when the light was born, the first flash. To understand where we are going, and to understand the ultimate fate of this light that shapes us, we must travel back, not just to the past, but to the origin of time itself. We must go back to the moment before the first star, before the first galaxy, to the time when the universe was a song without a singer. We need to talk about the cosmic microwave background, but not as a static hiss. We need to talk about it as the echo of the birth cry, because hidden in that ancient light is a secret, a pattern, a code that tells us how we got here. And it also tells us something unsettling about where here actually is. We are about to find out that the universe might not be what we think it is. It might not be a place at all. It might be a projection. Let us turn our eyes from the dark monsters of the present to the blinding fire of the past. Let us walk into the fire. Imagine standing in a thick fog, a fog so dense, so white and so hot that you cannot see your own hand in front of your face. This was the universe for the first 380,000 years of its existence. It was a plasma, a soup of subatomic particles, where electrons were torn loose from their atoms, roaming freely. And because free electrons are excellent at scattering light, a photon could not travel more than a tiny fraction of a centimetre before hitting something and bouncing off. Light was trapped. The universe was opaque. It was a glowing cage of energy. Then the universe cooled. The temperature dropped just enough to about 3,000 degrees Kelvin for the electrons to be captured by protons. Atoms formed. Suddenly, the fog cleared. The electrons were locked away in neutral hydrogen atoms, and the light was free to travel. In that instant, the entire universe flashed. A blinding burst of light was released from every point in space simultaneously. That flash is still travelling. It is the cosmic microwave background. But it has changed. Over 13.8 billion years, the expansion of the universe has stretched that blinding white light into invisible microwaves. It has cooled from the heat of a star to a frigid 2.7 degrees above absolute zero. But it is there. If you turn on an old television set between channels, about 1% of that static snow is the afterglow of the Big Bang interacting with the antenna. You are watching the creation of the universe. But this light is a wall. We cannot see past it. No telescope, no matter how powerful, can ever look before this moment. It is the surface of last scattering. It is the curtain that hides the singularity. We are surrounded by a sphere of ancient fire that marks the limit of our vision. We are inside a cosmic egg, and the shell is made of the oldest light in existence. When we map this light, as the Planck satellite did with exquisite precision, we see a baby picture of the cosmos. It looks like a mottled blue and orange football. The colours represent tiny differences in temperature, and these tiny differences are the most important things in history. If the early universe had been perfectly smooth, gravity would have had no purchase. Matter would have remained a thin, even mist forever. There would be no stars, no galaxies, no Earth, no us. But there were imperfections, tiny clumps of slightly denser gas. Here is a number that might scare you. The difference in density between the clumps that became galaxies and the empty voids was 1 part in 100,000. That is the margin of our existence. If the universe had been slightly smoother, we would not be here. If it had been slightly lumpier, the universe would be filled with nothing but black holes. We exist in the Goldilocks zone of imperfection. We are the children of a flaw in the fabric of the light. But where did these flaws come from? To answer that, we have to go back to the dark side of the theory. We believe that in the tiniest fraction of a second after the beginning, the universe expanded faster than light. This is called inflation. It took a patch of space smaller than a proton and blew it up to the size of a grapefruit in less than 1/billionth of a trillionth of a second. This violence smoothed out the universe, but it also took the tiny quantum jitters, the random fluctuating noise of the subatomic world, and stretched them into cosmic scales. The galaxies we see today, the great walls of light spanning millions of light years, are just quantum static stretched out by inflation. We are living inside a magnified quantum accident. This leads to a thought that reinforces our profound isolation. If inflation happened once, it likely happened everywhere. But it might not have stopped everywhere at the same time. The leading theory suggests that our universe is just a bubble where inflation stopped, allowing stars to form. But outside our bubble, inflation is still happening, creating other bubbles, other universes, forever. We are drifting in a multiverse foam, but we can never see the other bubbles. The space between us and them is expanding faster than light. The light from a neighboring universe can never reach us. We are alone in our bubble, creating our own meaning, forever cut off from the infinite family of universes that might exist out there in the dark. After the great flash of the release of the cosmic microwave background, the universe went dark again. The first atoms were hydrogen and helium. There were no stars, there were no galaxies. There was just a cooling, expanding sea of gas. We call this the cosmic dark ages. It lasted for hundreds of millions of years. The universe was silent. It was waiting. Gravity began to work on those tiny clumps we saw in the background radiation. It pulled the gas together. Slowly, silently, the pressure built. The gas fell inward, swirling, heating up. And then, in the deep dark, the first lights turned on. These were the population 3 stars. We have never seen one directly, though the James Webb Space Telescope is tantalizingly close to finding their chemical fingerprints in 2025. These stars were monsters. They were hundreds, perhaps thousands of times more massive than our Sun. They burned blue and hot, millions of times brighter than the Sun. They were the first lighthouses in the abyss. But they were tragic figures. Because they were so massive, they burned through their fuel with reckless speed. They lived fast and died young, exploding as hypernovae after only a few million years. But their death was necessary. The Big Bang only made hydrogen, helium, and a tiny bit of lithium. It did not make carbon or oxygen or iron or nitrogen. It did not make the stuff of life. The population 3 stars forged these heavy elements in their cores and then blew them out into the universe. Every atom of oxygen in your lungs, every atom of calcium in your bones, every atom of iron in your blood was cooked in the heart of a star that died billions of years before the Earth was born. The light you see today is made possible by the sacrifice of those first giants. They polluted the pristine universe with the dust of life. We are the nuclear waste of dead stars. But this era of first light was also an era of violence. The light from these first stars was energetic ultraviolet radiation. It slammed into the surrounding hydrogen gas and stripped the electrons back off. It reionized the universe. The fog that had cleared, then settled into darkness, was burned away again. The universe became transparent for the second time. We call this the epoch of reionization. It was a cosmic dawn where the lights turned on and burned away the shadows. However, the light does not just reveal, it also hides. And the ultimate hiding place is the black hole. When a massive star dies, if it is heavy enough, it collapses. It falls in on itself. The gravity becomes so intense that the escape velocity exceeds the speed of light. And since nothing can travel faster than light, nothing can escape. The star disappears from the visible universe. It leaves behind a hole in reality, an event horizon. For a long time, we thought of black holes as cosmic vacuum cleaners, sucking up light and matter and destroying them. We thought that if light fell into a black hole, the information it carried was deleted from the universe, gone. This terrified physicists. In quantum mechanics, information cannot be destroyed. If you burn a book, the information is technically still there, in the ash and the smoke and the heat, if you could just reassemble it. But if you throw a book into a black hole, and the black hole eventually evaporates, where did the story go? This is the information paradox. And the solution, or what we think is the solution, changes everything we think we know about reality. It suggests that the three-dimensional world we see, the stars, the planets, the depth of space, might be an illusion. Now, ask yourself, are you a physical object, or are you just data? In the 1970s, Stephen Hawking and Jacob Bekenstein realized that the information of the stuff that falls into a black hole is not lost. It gets plastered onto the surface of the event horizon. It becomes a 2D coating on the sphere. The black hole is not a pit, it is a hard drive. The surface area of the black hole encodes everything that is inside it. This led to the holographic principle. If a black hole can be described by the information on its surface, maybe the entire universe is the same. Maybe the three-dimensional experience of depth, of here and there, is a projection. Maybe the real reality is a two-dimensional surface at the edge of the cosmos, and we are just the hologram being projected into the center. The light we see, the photons bouncing off the walls, are the lines of code in the projection. We feel like we are moving through deep space, but we might just be information painted on a distant horizon. This would explain why gravity and quantum mechanics don't get along. One describes the paint, the other describes the canvas. We are characters on a screen, convinced we have depth. This idea creates a vertigo of the soul. We feel solid. We feel the weight of our bodies. But the physics of light suggests we might be ghosts in a machine. In 2024, researchers using quantum computers to simulate wormholes found that the math of teleportation through a wormhole is exactly the same as the math of information travelling through a quantum circuit. Space-time and quantum entanglement are the same thing. Space is not an empty stage. Space is stitched together by the ghostly connection of particles. If you sever the entanglement, space falls apart. The universe is a network of information. This brings a strange comfort to our isolation. We said earlier that we are trapped on Earth, that we can never leave, that the light separates us from the stars. But if the universe is a hologram, if space is just a projection of entanglement, then separation is an illusion. At the fundamental level, everything is connected to everything else in the data. The distance between you and the furthest galaxy is just a variable in the code. But let us return to the physical, to the melancholic reality of our position. Whether we are holograms or biological accidents, we are still bound by the speed limits of the projection. We are still waiting for the news. And the news is getting darker. We spoke of dark energy pushing the universe apart. But what is the ultimate fate of the light? As the universe expands, the density of matter drops. The stars will eventually burn out. The star formation rate in the universe peaked billions of years ago. It is already dropping. The party is over. The guests are just slowly leaving. The universe is getting dimmer. In about 100 trillion years, the last red dwarf star will flicker and die. The era of starlight will end. The universe will become a graveyard of black holes and cooling cinders. But even the black holes will not last. As Hawking predicted, they radiate away their energy. They will evaporate. One by one, the black holes will explode and vanish. And then? Then there will be nothing but photons, particles of light, stretched by the expansion until they have almost no energy, drifting through a void so vast that they will never encounter another particle. The universe will be empty, dark and cold. This is the heat death, the big freeze. It seems like a depressing ending, a slow fade into oblivion. But remember, we are creatures of the light, and there is one final twist in the story of light that we haven't touched yet. It is the story of how light creates time. Einstein taught us that light is the ruler by which we measure time. If you move fast, time slows down. If you travel at the speed of light, time stops. For a photon, there is no time. The moment it is born in the heart of a star, and the moment it hits your eye a billion years later, are the same moment. For light, the journey is instantaneous. It bridges the gap. This means that from the perspective of the light itself, the history of the universe is a singularity. All events happen at once. The separation we feel, the longing for the past, the fear of the future, these are human inventions. These are artifacts of our mass. Because we are heavy, because we are made of matter, we are dragged through time. We are forced to experience the universe as a sequence of losses. But the light is eternal. But what if we are looking at this upside down? What if the darkness at the end of the universe is not a death, but a reset? Some physicists, like Roger Penrose, have suggested a cyclical model. When the universe is empty, when only light remains, scale loses its meaning. If there is nothing to compare anything to, big and small don't exist. An infinitely large, empty universe, full of old light, looks mathematically identical to the infinitely small, hot point of a new Big Bang. The end might be the beginning. The heat death might just be the prequel to the next Let There Be Light. The ghosts of the old universe become the seed of the new one. The information we create, the signals we send, the light we reflect, might somehow imprint itself on that transition. So we are not just archivists reading the past, we might be the authors of the next cycle. The light we observe is the memory of the last universe, and the light we emit is the memory for the next. But that is a dream of the far future. Here, now, in 2026, we are faced with a more immediate problem. The light is being blocked, not by dust, not by dark matter, but by us. We are losing the night. For all of human history, the night sky was our primary connection to the cosmos. It was the canvas for our myths, our navigation, our science. It was the reminder of our scale. When you look up and see the Milky Way, you feel the cosmic mistake in your bones, the crushing weight of your own insignificance, which is the beginning of wisdom. But today, 80% of the world's population lives under light-polluted skies. We have erased the stars with our LEDs and our streetlights. We have built a dome of orange haze over our cities. Most children born today will never see the Milky Way. They will never feel that vertigo. They will look up and see a blank, grey ceiling. We are blinding ourselves. We are turning the windows of our spaceship into mirrors. When we look up, we see only our own reflection, our cities, our satellites, our debris. We are cutting the optical fibre that connects us to the universe. In 2024 and 2025, the problem moved to orbit. We launched mega constellations of satellites, tens of thousands of them. They reflect sunlight. They streak across the long exposure images of our telescopes. We are putting bars on the prison window. We are trapping ourselves, not just physically, but visually. If we lose the view of the stars, we lose the context of our existence. We risk forgetting that we are on a rock floating in a void. We risk thinking that the earth is the whole world, that our petty political squabbles and our economic cycles are the only things that matter. The silence of the universe is a gift. It tells us to be quiet and listen, but we are drowning it out with our own noise. This is the spiritual crisis of modern astronomy. Just as we are building the tools to see the edge of time, we are drawing the curtains. We are choosing the comfort of our own artificial light over the cold, hard truth of the starlight. And this brings us back to the earth, the only place we can live. The only place where the light is warm enough to sustain us, but soft enough not to kill us. We are children of the sun, yes, but we are also children of the dark. We need the night to sleep, to dream, and to wonder. As we stand here, illuminated by the ancient photons of the Big Bang and the fresh photons of our artificial cities, we have to make a choice. We are the custodians of the light. We are the only eyes the universe has. If we blind ourselves, the universe goes back to being unseen. It goes back to being a ghost. We have explored the past, the present, and the deep structure of reality. We have seen that light is a time machine, a limit, and a code. But there is one final aspect of light that we must confront. It is the most personal one. It is the light inside us. Not a metaphor, real, biological light. The electricity that runs your brain, the chemical energy that powers your cells. It is all trapped sunlight. We are not just observing the universe. We are made of the same energy that burns in the stars. We are a temporary storage device for cosmic fire. And this realization leads us to the final chapter. If we are made of light, and if light is information, what happens to the information that is us when the biological machine stops running? We are about to look at the ultimate horizon, not the edge of the universe, but the edge of ourselves. The story of light ends where it began, with the mystery of consciousness, with the cosmic mistake trying to understand why it shines. Every thought you have, every movement of your hand, every beat of your heart is powered by a photon that was forged in the core of the sun 1,000,000 years ago. That photon fought its way out of the star, travelled 93 million miles of vacuum, and smashed into a chloroplast in a leaf. It was captured. Its energy was stored in a chemical bond. You ate the plant, or you ate the animal that ate the plant. You broke that bond. And now that ancient sunlight is released inside you to power your life. You are not just living in the light, you are eating it. You are a biological engine designed to process stellar energy. We tend to think of ourselves as separate from the physical universe. We think of the environment as something outside of us. But this is a delusion. We are continuous with the cosmos. The iron in your blood is the ash of a supernova. The water in your cells is the melted ice of comets. And the energy that drives your consciousness is the liberated light of the sun. When you have a new idea, when you feel love, when you dream, you are burning the ghost of a star to fuel that experience. Now ask yourself, if the sun went out, how long would your consciousness last? This dependency reveals our fragility. We are not self-sufficient. We are tethered to the nearest star by an umbilical cord of light. If that cord is cut, or if the light changes even slightly, we vanish. We are a momentary fluorescence on the surface of a rock, a brief chemical reaction that has learned to call itself human. But this reaction has done something extraordinary. It has become aware of the light. Inside your skull, in the silent darkness of the brain case, there is a storm of activity. 86 billion neurons are firing electrical signals. Ions are rushing across membranes. This is the internal light. It is the biological equivalent of the stars. And just as the gravity of the galaxy binds the stars into a structure, the architecture of your brain binds these flashes of bioelectricity into a mind, into you. This is where the story of light becomes the story of meaning. The universe, for 13.8 billion years, was a play of forces: gravity crushing gas, fusion releasing energy, light travelling through the void. It was magnificent, but it was meaningless. There was no one to appreciate the scale. There was no one to feel the tragedy of the dying stars. There was no one to marvel at the sunrise. Until us. We are the cosmic mistake that woke up. We are the accident that gave the universe a voice. When you look at the stars, the universe is looking at itself. When you study the spectrum of a distant galaxy, the universe is reading its own diary. We are the sensory organs of the cosmos. Without us, or beings like us, the light would still exist, but it would be unseen. It would be irrelevant. This places a terrifying weight on our shoulders. In the files of our existence, we often look for a grand purpose. We want to be the chosen ones. We want to be the explorers who conquer the galaxy. But the physics of light, as we have seen, forbids this. We cannot conquer the galaxy. The distances are too great. The speed limit is too strict. We are confined to this solar system, likely forever. But what if our purpose is not to conquer, but to witness? If we are truly alone, or if we are the only ones in this corner of the galaxy who have awakened, then we are the custodians of meaning. We are the librarians of the night sky. If we destroy ourselves, if we let our civilization collapse, it is not just a tragedy for humans, it is a tragedy for the universe. It means the lights go out. It means the universe goes blind. Here is a number that might scare you. The probability of life evolving on a planet is incredibly small. The probability of that life becoming complex is even smaller. The probability of that complex life developing the technology to see the universe is vanishingly thin. We might be the only ones. In the entire observable universe, with its 2 trillion galaxies, we might be the only eyes open right now. The silence we hear when we listen to the stars might be the true state of nature. We are the anomaly. This silence is known as the Great Filter. It suggests that there is a barrier, a hurdle that prevents life from spreading. Perhaps civilizations destroy themselves as soon as they discover nuclear physics. Perhaps they retreat into virtual realities and stop looking up. Or perhaps, as we have discussed, the sheer vastness of space and the lethality of cosmic radiation keep everyone locked in their home systems. If this is true, then every photon that hits our telescopes is a precious commodity. It is a message that has travelled for millions of years to reach the only recipient who cares. We are the bottleneck of cosmic memory. If we don't write it down, if we don't understand it, the history of the universe is lost. This perspective shifts our view of the prison of Earth. We often resent our confinement. We want to be Star Trek. We want to warp drive to the next nebula. But the universe has said no. The laws of physics are the bars of our cell. But maybe, just maybe, this cell is a sanctuary. Think about the violence of the universe we discovered. The black holes shredding stars, the gamma ray bursts sterilizing galaxies, the hard radiation of the deep void. If we could travel easily, we would likely be destroyed. The distances that isolate us also protect us. The speed of light limit ensures that no hostile civilization can easily attack us. It ensures that the contagions of the galaxy, biological or technological, cannot reach us. We are quarantined. And in that quarantine, we have been given a paradise. We have a planet with a magnetic shield that deflects the solar wind. We have an atmosphere that filters out the deadly UV light. We have a temperature range that allows water to flow. We have a stable star. We have a moon that stabilizes our tilt. We have won the cosmic lottery. And yet, we spend our time dreaming of Mars, a frozen, dead, radioactive desert. We dream of leaving the womb to play in the traffic of the cosmos. We need to grow up. The cosmic mistake is not that we are here. The mistake is thinking we belong somewhere else. The light tells us that we belong here. Our eyes are tuned to the sun. Our skin creates vitamins from its rays. Our sleep cycles are locked to the rotation of this planet. We are not tourists on Earth. We are not passengers waiting for a better ship. We are the ship. We are the Earth, evolved into a form that can walk and talk and look up. And as we look up, we see the final lesson of the light. It is fading. We spoke of the heat death, the ultimate end of the universe, but there is a more immediate fading. The era of starlight is finite. We are living in the stelliferous era, the time of stars. It will last for another 100 trillion years. That sounds like a long time, but compared to eternity, it is a blink. We are living in the brief flashbulb moment of the universe. Before this, there was darkness. After this, there will be darkness. We are the creatures of the flesh. This means our time is limited, not just our personal lives, but the life of our species and the life of the universe's ability to be known. We have a deadline. We have a responsibility to learn as much as we can, to feel as much as we can, to create as much beauty as we can, while the lights are still on. But what if we are looking at this upside down? We fear the dark. We fear the end of the light. But light requires darkness to be seen. A candle in a bright room is invisible. A candle in a cave is a beacon. Our significance comes from the darkness that surrounds us. If the universe were full of life, full of noise, full of light, we would be nothing, just another ant's nest in a forest. But because the universe is dark, because it is silent, because it is empty, we are everything. We are the candle in the cave. And the light we cast is not just the physical light of our cities, it is the light of our knowledge. Every time a scientist figures out how a black hole works, the candle burns brighter. Every time an artist captures the feeling of a sunset, the candle burns brighter. Every time we choose kindness over violence, the candle burns brighter. We are pushing back the conceptual darkness. This is why we must solve our problems here. We cannot export our chaos to the stars. The universe will not allow it. The distances are too vast. The energy requirements are too high. We are forced by the laws of physics to sit in our room and sort out our mess. We have to learn to live together on this one fragile rock. There is no planet B. There is no warp drive escape hatch. There is just us, the Earth, and the Sun, and the ghosts. Let us return to the idea of the universe as a library. The light we see is the memory of the past. But what about the light we emit? The radio waves from our broadcasts, the light reflected from our cities. This is rushing away from Earth at 300,000 kilometers per second. It is forming a sphere of history that is expanding into the galaxy. Long after humanity is gone, long after the sun has swollen into a red giant and consumed the Earth, that sphere of light will still be travelling. It will carry the image of the Mona Lisa, the sound of Bach, the speeches of dictators, the cries of newborns, the data of the internet. It will carry the story of the cosmic mistake that learned to love. Someone, somewhere, 1 billion years from now, in a galaxy far away, might point a telescope at the spot where our sun used to be. They won't see us. We will be dust. But if their instruments are sensitive enough, they might catch the faint, stretched out ripple of our radio waves. They might hear a whisper from the past, and they will know that once, in the quiet suburbs of the Milky Way, there was a species that looked up. They will know that the universe was not always dark. They will know that for a brief, shining moment, it was alive. So, when you stand under the night sky, do not feel small. Do not feel crushed by the size of the cosmos. Feel the connection. The light hitting your eye has travelled across time to find you. You are the destination. You are the witness. You are the reason the stars are shining. The universe is a vast, cold, indifferent machine. It grinds galaxies together. It freezes planets. It burns stars. It does not care about us. It does not know we are here. But we know it is here. And in that knowing, we win. We steal a victory from the void. We are the archivists of the twilight. We are the keepers of the flame. And as long as we are here, as long as we keep looking up, as long as we keep asking questions, the universe is not dark. It is illuminated by the most powerful light of all, the light of a conscious mind refusing to surrender to the silence. The stars may die, the galaxies may drift apart, the universe may fade into a cold, black void, but we were here. We saw it, we understood it, and in the library of the cosmos, that entry will never be erased.